is inverse notation. So this is read F inverse of X. Now, you did this last year. Who remembers anything about it? Caitlin?
Don't you just change the X's for the Y?
So, well, first of all, I'll remember F of X is the same as Y. Right? And then she said, switch the X's and the Y's. Like that?
Mm-hmm.
And then what?
Solve for Y?
Solve for Y, which means get Y by itself. So your inverse would be this. Now, I want you to think about this logically for a minute. Let's go back to the original function. If you feed it a number, remember it's an input-output machine. Functions, you put something in and something comes out. If you put in a number like, let's say, 4, okay, you put in 4. What's the first thing this function's going to do to it? Multiply by 3. So think of it as a step-by-step process. It's going to times by 3, and then it's going to subtract 7, and then it's going to divide by 4, or 7, subtract 4, divide by 7. Now, put that machine in reverse. Remember, it times by 3, subtracted 4, divided by 7. Put it in reverse. Undo that. The first thing you have to do is times by 7, add 4, divide by 3. And isn't that exactly what the inverse does? Makes completely logical sense. Now, let's suppose you did put a 4 into the original. Just a random number, nothing special about 4. You put 4 in, and what would come out of the original? 8 sevenths. All right, let's take that 8 sevenths now and put it into the inverse. Don't panic. What's 7 times 8 sevenths? 8. Plus 4 is 12, divided by 3 is 4. Is that exactly what you expected to happen? Yes, because if inverses undo each other, then whatever F did to 4, F inverse is going to undo and get me back to my 4 again, right? So what happens to ordered pairs in inverses? They are flipped, which makes perfectly good sense if we go back to what Caitlin said. From the beginning, what did we do? Switched our X's and Y's. So that's how it manifests itself in the graph. The points, the coordinates are switched. Okay? All right, easy stuff. Very important stuff, though. Let's do a harder one. Let's suppose this is the function. And we want to find G inverse. Okay, so how do we start? What are our steps? Think about what Caitlin suggested. Maybe we should be doing that again. What do you think? Step 1. Let's replace the G with a Y. And then, yes, Nicole, we will switch X and Y. Okay? Okay, this is a participation sport, not a spectator sport. So let's wake up, pay attention. Here we go. What might we do now? Riley?
Multiply both sides by 5y plus 1.
Yeah, let's get rid of that denominator. Everybody good with that algebra? Just bring in the denominator over so we don't have a fraction anymore. And then, Caroline?
Oh, I had a question
Uh-huh.
about why wouldn't we do multiply by 5y minus 1? I thought that was how we cancel.
Okay, now be careful. You're thinking about the conjugate, and we multiply top and bottom by the conjugate when there's something in the bottom that is not allowed. So like a radical or an I, multiplying top and bottom by the conjugate does not eliminate the fraction, which is what we're trying to do. So we're just, this is like having an equation like 3/5 x equals 4. You would multiply both sides by 5 to get rid of the fraction. That's all we're doing here.
Okay.
All right, suggestions?
At 8.
At 8?
Divide by 3.
What do you think, peeps?
I don't know. I don't like the Y.
I mean, yeah, that's right. This is kind of messy. We could, clean that up a little bit. But that's not the problem. The problem is we're supposed to be solving for Y, and we have a Y. Right? So I think we need to rethink this. Back to the drawing board. What do you want to do here? Brittany?
Could you add the 3 and the 5 together? Or like subtract 3 from 3y from those?
Okay, now I gotta be careful. This is still buried in a parentheses, so let me get him out of the parentheses. And then, Brittany, I love your idea. I'm gonna do what you suggested, but I can't combine them because this 5y is attached to an x. But I do want to get them together on the same side of the equation. So 5xy minus 3y, and I'm going to go ahead and move that x to the other side. Notice, like Brittany suggested, we're trying to get all our y's together on the same side. This did not have a y, so I moved him over to the other side with the 8. So now I have one side of my equation with y's, and the other side of the equation with other things, not y's. Riley?
Could you divide by x to get rid of the x and the 5yx?
You could, okay, first of all, dividing by x is dangerous and scary. We have to be sure it can't be 0. But dividing by x isn't going to fix the problem because it'll take care of it on this term, but it's going to show up right here.
Oh.
So then I'm going to have, instead of an x times a y, I'm going to have a y divided by an x, which is just another problem. Kendall?
Could you like not factor the field, take out a y out of that?
What's wrong with your arm?
Nothing. I don't know nothing about it. You got a y?
Yes, we're going to factor out a y.
Okay.
We're going to factor out a y. I forgot to turn my phone off. So we're going to factor out a y, and we're left with 5x minus 3. Now we're almost there. What was our objective?
Get y.
Get y by itself. So guess what I'm going to do now?
Divide it.
I'm going to divide by 5x minus 3. Now I want to show you something. Well, first of all, before I start talking about that, that was the original problem. This is my inverse. This was the original, this is my inverse. Now, did everybody follow all those steps? Okay. Thinking in terms of what we have been talking about, let's look at this original function. All right? What is the domain of this function? The original. What's the domain of the original?
Negative
X cannot be
negative 1/5.
negative 1/5.
Oh, that's
Because
That's
what
right.
would happen if x were negative 1/5? You would have a 0 in the bottom, and that is not allowed. Tell me about the range of this function. Now, do not be confused by that. This is a variation of the reciprocal function. So it's going to have, I have no idea what it looks like, but it's going to have a couple of asymptotes, and it's going to have a shape that looks like this, right? So the reciprocal function goes up forever and down forever, but there's one y value that's excluded, right? Where's the horizontal asymptote of that guy? 3/5. So your range is everything except 3/5. Now let's do the same thing with the inverse. Tell me about the domain,
Why can't he do 3/5?
X
the
can
domain.
Okay,
X can't equal negative 1/5, or X can't
3/5.
equal, I'm sorry, 3/5. And my range is Y can't equal negative 1/5. What happened? They're flipped. Does that make sense to us that they would be flipped? Yes, because why? When we're talking inverses, x's become y's and vice versa. So whatever x couldn't be in the original is going to become a y can't be in the inverse. Which is easier for you to find, domain or range? Domain, right? Usually domain is easier. So let me give you a little hint now. If somebody gives me a question and says, Lisa, find the range of this, an option I now have is to find the domain of the inverse. I'm good at finding domain. So if I can't figure out what the range of something is, if I can find its inverse, see where I'm going? The domain of the inverse becomes the range of the original. So it's just another tool in your toolkit. Whenever you're struggling with range, think about it in terms of the inverse's domain. They'll always match up. Okay? So we're really, well, never mind. Stop right there. Okay. All right, one more comment about inverses and then I think I'm done. Suppose that I gave you a picture. And those are all, those points are right where they look like they are. Like this is the point 1, comma 2, negative 1, comma 2, and so on. Okay? And I said to you, sketch the inverse. Sketch the inverse. Now you don't have an equation. We're just going to sketch the inverse. What's your thought on that? Jada? Okay, it's got symmetry, absolutely, but not across the origin. Remember, Jada, when you have symmetry across the origin, the point 1, 2 would become the point negative 1, negative 2. We're doing inverses, so what do we need to have happen to the point 1, 2? What does it need to become if it's an inverse point? It needs to flip, so it's going to become 2, 1. So that's not symmetry about the origin, that's symmetry about the line y equals x. So we're going to see it. Here we go. What's going to happen to this point? This is 0, comma 1, so it becomes 1, comma 0. 1, comma 2 becomes 2, comma 1, as Jada said. Negative 1, 2 becomes 2, negative 1. 2, comma 1, 2, 3, 4 becomes 4, comma 2. And negative 2, 4 becomes 4, negative 2. So there's the inverse. Notice that it is the reflection across the identity. So when you said there was symmetry, you were exactly right, but it's across the identity. So if someone gives you an equation, we've practiced how to find the inverse. If someone gives you a graph, we've talked about how to get the inverse, right? We just switch the ordered pairs. So if we had, thinking of our BFFs, if we had a trusty sine curve, anybody want to take a wild guess what the inverse of that's going to look like? Inverse sine function is kind of a biggie. JD, you're exactly right. She's over there going like this, and she's right. Think about it. If the original sine oscillates across the x-axis, then what's the inverse going to do? Oscillate across the y-axis. Because why? Inverses switch ordered pairs. So whatever used to happen to x will now be happening to y. Right? The inverse sine then is not a function, right? That's a problem for us. We got rules. When we get to that chapter, we'll have to learn them. It is not a function. Okay, let me make a list now of everything that's due on Monday. And you have 4 minutes. So you can either just relax and chill out, or you can start. But this is what's due on Friday, or Monday. It's all 1.5. So that is what is due on Monday, part 1.5.
Is this in the book or the packet?
That's in the book.
Okay.
That's in the textbook.
I'm